Let's talk about DevOps. As you can see from this DevOps landscape map, DevOps is a large and rapidly changing space. In fact, this was done in 2017, and things have only gotten more complicated since then. I'll do my best to simplify it for you. While it had its roots going much earlier, the DevOps movement truly began in 2008 when Patrick Dubois and Andrew Clay Schaefer had a discussion about Agile infrastructure. That discussion spawned the DevOps days in Belgium a year later. So DevOps began as the application of Agile principles to everything that happens after the software is written. Much like Lean and Agile aim to break down the silos between requirements, development, and testing, DevOps aims to break down the silos between development and operations, hence the name DevOps. This seems like a good time to mention that if you are building a DevOps team, then you're probably going against the original intent of DevOps. It's about less silos, not more. These days, DevOps has expanded to include other activities that traditionally occur after development, such as security. In fact, some people prefer to talk about DevSecOps. DevOps also has a strong focus on automation to allow teams to work smarter, not harder. DevOps is a big topic, so we're going to dive into a few of the more important areas. This brings us to our first subject, which is continuous improvement. We aren't going to spend a lot of time on this, as much of what we have learned from Agile software development, such as having retrospectives, applies directly here. One area that does merit discussion is what is usually called incident postmortems. More progressive organizations often call them blameless postmortems, actual retrospectives, or learning reviews. We like to call them blame-aware postmortems. Whatever you call it, postmortems are how you turn the inevitable mistakes or failures that will occur into learning experiences that make your organization better. Great teams know that things will go wrong, so they design for fast detection and recovery, and then they learn from their mistakes. I highly recommend the book Beyond Blame to learn more. Continuous improvement and a postmortem philosophy are also key to Google's site reliability engineering approach. Now, let's talk about continuous delivery. Continuous delivery is an extension of continuous integration that automates the deployment and releasing of software. This removes the error-prone practice of manual software releases, which has plagued software since its earliest days. Fully automating your build, deploy, test, and release processes improves collaboration between developers, testers, and operations, and dramatically lowers both the cost and risk of deployments. While many large organizations only release software every 3 or 6 months, organizations that adopt continuous delivery often release several times a day. In fact, I ran an experiment called Project Ludicrous several years ago to see just how far you can take this concept. With Project Ludicrous, we were working in pairs, with each pair releasing to production from 10 to 30 times per hour. While this worked surprisingly well and had some beneficial side effects on other development practices, I am not recommending that you take things to that extreme. There's a reason it was called Project Ludicrous. It does, however, show what is possible when you automate and optimize your continuous delivery pipeline. You may be wondering about the business value of releasing to production frequently. DORA, the DevOps Research and Assessment Organization, was purchased by Google Cloud. They have been conducting the largest study of development practices and their impact on business success. This isn't your typical industrial survey. DORA's work was across tens of thousands of organizations over the course of 7 years and has been published in peer-reviewed journals. Their State of DevOps report shows that deployment frequency is highly correlated with increased business performance. Their research shows that elite organizations release on demand multiple times per day and made up the top 20% of organizations in 2019. The 23% of organizations that release between once per day and once per week fall into the high performance category. And organizations that release between once per week and once per month fall into the medium performance category. Organizations that released only once per month or up to once every 6 months fall into the low performing category in the bottom 12% of overall performance. Another key metric studied by DORA is lead time for changes. This metric is also directly impacted by continuous delivery. DORA defines lead time for changes as how long it takes to go from code committed to code successfully running in production. Elite organizations have a lead time of less than 1 day. High-performing organizations have a lead time between 1 day and 1 week. Medium-performing organizations have a lead time between 1 week and 1 month. And low-performing organizations have a lead time between 1 month and 6 months. DORA's work is definitely worth studying. Their annual State of DevOps report is full of information on how the best organizations are building software. The people behind DORA have also written 2 excellent books. Accelerate, which is for those managing a DevOps transformation, and the DevOps Handbook, which is for those at the ground level of a DevOps transformation. Our next DevOps topic is infrastructure as code. Infrastructure as code manages and automates the creation and change of the systems your applications run on top of. It is also a key part of the tooling behind continuous delivery. There are a lot of tools in this space, including Terraform, CloudFormation, and Pulumi. Infrastructure as code adopts many development practices such as version control and automated testing. Now let's talk about shifting left. This refers to the practice of taking the approvals, audits, and other activities that are done after development, but before release, and automating them in your continuous integration and delivery pipelines. One of the most common of these activities is security reviews. Before adopting shift left on security, many, perhaps most developers, pay minimal attention to security issues and expect the security team to notify them of any problems. Security reviews are scheduled after the software is considered complete, and the security team often becomes a scheduling bottleneck. When security issues are found, they must then be scheduled for development to fix, which often leads to the difficult decision to either release late or release with known security issues. When you shift left on security, development collaborates closely with the security team to integrate their audits into the continuous delivery pipeline, where those audits are performed continuously each time code is checked in. This lets developers know there is a problem while they are still working on a story, and fix it on the spot and requires no direct interactions with an external security team while delivering the story. While we've been talking about shifting left on security, this same approach can apply to many other activities that traditionally occur after the software is completed, such as performance testing or accessibility audits. When you've adopted shift left, you can feel confident that your software is really done when development and automated testing is complete. Earlier, we talked about 2 of the 4 metrics DORA found correlated with organizational performance. Now, I want to cover the other 2 metrics. The third DORA metric is time to restore service, which they define as how long it takes to restore service when a service incident, such as an unplanned outage or defect that impacts your users, occurs. Elite organizations restore service in less than 1 hour. High and medium performing organizations restore service in less than 1 day. And low performing organizations can take between 1 week and 1 month before service is fully restored. DORA's final metric is change failure rate, which they define as the percentage of changes to production or releases to users that subsequently require remediation. For this metric, elite, high, and medium performing organizations all have a change failure rate of less than 15%, while low performing organizations have a change failure rate of 46 to 60%. DORA's research is the closest thing we've ever had to scientific proof in the software industry, and it teaches the metrics and practices that improve business performance.